Hello and welcome. This course is designed for total beginners and programmers new to C programming language. In this video, you will be learning the fundamentals of C programming language. If you want to do a project using C, then this video provides a foundation for you to do so. Here you will be learning the theory and doing the code at the same time. So I recommend you to not only watch this video but do the code yourself. So best of luck to you for this course and let's get started. Computer is an electronic machine that takes instructions, processes it and gives the required output. Programming is basically giving those instructions to the computer. Whenever we want to program a computer or give instructions to the computer, we write the code in high level languages such as C programming language. Then we run the code or compile the code. Then the high level language is converted into low level language or machine code, which is basically 0 and 1. This is only the form that computer understands. So after being compiled, the code will be changed into machine code and the computer will get the instructions that we wanted to give. So basically C is one of those high level programming language in which we write the code. In fact, C is the god of all programming language. It is not only used to write applications but even operating systems like Windows and many other complex program also. It has inspired many programming languages, and if you understand the concept of programming in C, then it will be very easy for you to learn any other languages. So with that said, let us begin the tutorial. For this project, I will be using the CodeBlocks IDE. You can just use any IDE of your choice, but if you want to get CodeBlocks, you can go to codeblocks.org. The installation is pretty simple, and when you open the CodeBlocks, then this is the page that you should come to. Now we just cut this and go to File, New, Empty File, and click on Empty File to open a empty file. Now we press Ctrl S to save this. Now the thing that I wanted to show you was the format of a C file. A format of the C file is in .c. Its extension is .c. So we'll save it as hello world.c. Now we just save it. Yes. So once you've saved this in a .c format, the IDE already knows that this file is a C file. So it will use the C compiler to run this file. Let's just move on to the hello world code. So let us first try to print a program to display hello world on the screen. This is the most basic program that we can do. So let's just start by including our header file by writing include stdio.h. Let us just talk about this line of code a little bit later. Let's just jump into our function called main function. Int main, this is the syntax of the main function, and any important code that we will be writing is inside this main function. Whenever the C program is running, whenever the code is executed, the control comes inside the main function. The code starts from here. Okay, so if I want to print hello world, I'll just write printf, and inside of it I'll write hello world. All of these is inside the main function. I write my code inside the main function, and we denote the end of the line of code by using a terminator character, which is of course a semicolon. Let us just talk about the syntax of the main function for a bit. The main function is this, and before the main we write int. Int stands for integer, and it is the return type of the main function. It suggests what the main function returns. In C, we use a return keyword, and suppose if we want to return 8 or we want to return some value, then we just use a return and then give the value. But here we are not returning anything, we are just printing hello world. So we just write return 0 and then close it. Let us just run this code, and after that we will just talk about the first line. Let us run this code, and what is printed? Hello world is printed in the screen. This is exactly what we wanted. Here note that hello world is written inside double quotes and two brackets, and this printf function's task is to print whatever is written inside of it. So let us all know that stdio.h stands for standard input output, and inside of it we contain functions that help in this purpose of standard input output. One of them is printf. So if you want to use any functions like printf, then we have to include its source library, which is stdio.h, by using hash include. So we can just write it as a note that printf function is inside the stdio.h file, h header file. Okay, so if you want to see, if we want the compiler to see this line as a note, then we'll just write double slash. Now this whole line becomes a comment after this. Okay, so if even if I run this now, no error will be shown. The code is running fluently. I can even write a multi-line comment, like write comments over a few lines by using slash asterisk for opening the comment and asterisk slash, asterisk and slash to end the comment. And I can write just anything inside of it for as many lines as I want, and the compiler will just ignore it. It will just run whatever is outside of it. Okay, so these are the things. So this is the first code that we have written, and we'll be doing a little bit more advanced stuff now. We'll be writing a code to print the sum of two numbers. Okay, so let us do that. So this is just the basic format. Whatever code we'll be writing it inside of here, we'll be writing it here. Okay, so let us first learn how to declare a variable. In order to use a variable, we must first declare it. Let us first declare, like for example, we write int a. So this means some space in the RAM is allocated for a variable called a. Now we can store anything inside this space, like a equal to 5, but it must be an integer value as we specified by int. Okay, now we can also allocate another like b, int b, and we can also write b equal to 9. Okay, so and give a semicolon. But we can do both of these in a single line as follows: int a comma b will allocate space for both a and b. Okay, and both of them will be integer type, so we can only assign b equal to 9. We cannot assign like b equal to hello. We cannot do this because b is an integer. Okay, and let us just declare another variable called sum. Basically we want to add these two variables and store the result in the space called sum, because sum is also a variable. It contains some space, right? And inside it we write a plus b plus b. Okay, so let's just try to print sum. Print f. The sum is, and what is the sum? The sum is an integer value. It is sum, but we can't just write the sum is sum. It will just print the sum is sum. If you want to print the variable sum, then we should write a placeholder called %d. %d is a placeholder for integer value. We can just specify what is in that place by after writing a comma and writing it after the double quotes close. Okay, so this will just print the sum is, and then it will place the value of sum inside this placeholder. Okay, so let us just run this code. And the sum is 13. Yes, absolutely, the sum of 5 and 8 is 13. Okay, but let us try to make a program that will allow the user to enter the numbers that it wants to be added. Okay, so let us just write printf to notify the user to add something, like write the first number, right? Write the first number. Now this will be displayed to the user, and now we should give him the interface. Now we should give him the facility to enter some number. We do that by using scanf function. Again, the scanf function is inside the stdio.h, and we write a placeholder to in order to let the user to enter something. Okay, and what is in the and where should we store what is written in the placeholder? We should store it in a. We write it at a to denote the address of a. We write %a to denote the address of a, because we're storing the value at the address, at the memory address of a. Now we give a semicolon, then again we write printf, and then we write the or enter the or write the second number. Then we give a semicolon to denote the termination. Now we write scanf, again a placeholder for integer value. Then we write comma and ampersand b. The first number is now stored in a, the second number is stored in b, the sum is stored in sum, and the sum will be printed. So let's just run this code. So it tells us to write the first number, which is 45, the second number will be 5, then the sum is 50. Okay, so everything is correct, everything is going nice. And now what we want to do is we want to print, we don't want to print that the sum is this, we want to print that the sum of this number and this number is this. So for that we write the sum of what, integer value which is denoted by percentage %d, and another integer value which is denoted by percentage %d is another integer value. So what is the value of the first percentage %d, first placeholder? It is a, for the second one it is b, and for the third one it is sum. Notice how in scanf we use ampersand a, but in printf we just use a, b and sum. Okay, so because this is for storing, right? So here we should use ampersand, but here we should not use ampersand. So let us just run this code and see what it does. The first number I will enter it as 10 and the second number is 9. The sum of 10 and 9 is 19. This is what we wanted. Okay, so let us try to do a program to like calculate the difference as well. So the process is exactly the same. We just declare another variable of integer data type called diff, and we just print. So we don't even have to do this. I'll just teach you another way. Printf and the sum of the difference of percentage %d and percentage %d is percentage %d. Okay, and the what is the value of the first one? The value of the first one is a, the value of the second one is b, and the value of the third one is a minus b. We can just write that here itself. We don't have to use an extra variable. Okay, so here also we could have written a plus b here itself. So let us just run it and see what happens. So let us write 20 and let us write 5. So the sum of 20 and 5 is 25. The difference of 20 and 5 is 15. So we wanted a good little space between it here, like a good little line between this. So we can just add a new line character after this. The sum of this and this is this, and after that we just give a new line character. Then run this. So we write 40, the second number is 20. Now the sum of 40 and 20 is 60, the difference is 20. This is what we wanted. But if we see at the normal calculator that we use, or the calculator at our mobile phone, is this how we enter it? No, this is not how we enter it. We just write 40 plus 20 and the result should be shown itself, because everything should be automated, right? So we will not show two results, but whatever the user specifies, we will show it. So it becomes a conditional. So if the user writes plus, then we should do the addition. If the user writes minus, we should do the subtraction. In these kind of cases, what we use is we use switch case statement. So let us use the switch case statement. Using the switch case statement, we first declare a variable of a character data type. We just call it sign. The sign will be used to, the sign variable will be used to denote, like to store the sign that will be entered by the user. Like the user this time will be entering 2 plus 5, something like that, right? So the plus will be stored in this character variable sign. Now the way we take input should be changed also. So we write the calculation that you want to do. Okay, now inside the bracket we write we only do addition and subtraction. Okay, so this is all we'll be doing, and after that multiplication, division,
they're all easy, just we should only change the operator and the process is the same. So we'll just be doing addition and subtraction. Now we'll be changing the way we take input. Scanf percentage %d, we're going to be taking something like 2 plus 5, right? So the first thing is an integer, the second is a character, the third is again an integer. Okay, like this is a number and this is a sign and this is a number again. So the first will be stored at the address of A, the second will be stored at the address of sign, and the third will be stored at the address of course B. Okay, now the code for taking B in, we can delete it. Now sum equal to A plus B. So here we will be using the switch case statement now. Now first we write switch. Inside of it we write the operator. I mean the variable in which the operator is stored. It is signed. Okay. So now after this we will start a curly braces, and inside of it we write all the cases that this sign can take. The first case is that case in which the value of sign is plus. In this case we just have to print. What do we have to print? Okay, so let's just copy and paste this. So let's just copy and paste, cut and paste this line of code here. So in case of plus we're going to be doing the addition, we're going to be doing the sum. In the case this is minus, we'll be pasting this code here. In the case of minus we'll just be pasting this. Okay, now we also have a default keyword in the switch case statement, and here we'll be writing anything. So if the user enters like a asterisk b, then we'll not be doing the like multiplication, right? So we'll just write printf, please enter a valid like calculation. So this will be the default statement. If none of these are executed, then also this will be executed. Now yet this is not completed. This switch case statement is not completed, but first let's run it and let me tell you what is lacking in this. Okay, so we just missed a semicolon here. We missed a semicolon again. Okay, now build and run this. Okay, so write the calculation that we want to do. We want to do 5 plus 9 and then we press enter. Now what is printed is the sum of 5 and 9 is 14. That's good, but what is also printed is the default. The difference is 5 and 9 is -4. It is also printed, and please enter a valid calculation. Everything is printed. So what we want to do is, once our one of the cases is satisfied, we just want to break out of the switch case. So we just want to break out of the switch case statement. So in after everything we write break. Okay, here we don't need to write break actually, but let's just do it anyway. So now let's run this. I'll write 8 plus 99, and the sum of 8 and 99 is 107. Okay, so this was the switch case statement. So now let's move into the if else statement. So I just made a new file and I just wrote the main function and just included stdio.h. Now inside of it we're going to be writing a program that takes two inputs from the user, two numbers from the user, and then compares them, like tells which one is greater, which one is smaller, or they are equal. Okay, so we'll be doing that using conditional if else. Okay, so first we're going to be declaring two variables a comma b as an integer, because here this is where we're going to be storing the numbers that we will take an input. Okay, take as an input. Print f, we write enter the two numbers separated by comma. Okay, so we're just going to be doing a basic program. Now scanf, and inside of it we're going to be taking a integer, then we're going to be taking a comma, then we're going to be taking an integer. The first integer will be stored at in the address of a, then the second at b. So now we're going to be giving a semicolon. So we missed a comma here, so we're going to be adding a comma. Okay, so now we will begin our if else statement. First we write if, then inside of it, inside brackets, just parentheses, we just write the condition. Okay, and after that inside curly braces we write the code to be executed if the condition is true. After that we write else if, then again we write another condition. We can write as many of these as we want, and then we just open the curly braces, and inside of it we can write anything. And after that we just write else, as now we do not need any condition, and we just give the code to be executed. We just write the code to be executed. Okay, so for the first if, the condition is a is greater than b. So what to do if a is greater than b? We'll just print what do we print? Percentage d is greater than percentage d. Now for the first percentage d it is a, and for the second it is b. Now we give a semicolon. And else if b is greater than a. Now for this we do is the same, just the places of b and a are to be interchanged. We just paste this, and in place of a we write b, and in place of b we write a. But for else we write printf the numbers are equal. So this is what we wanted. So first the compiler will try to do this code. If it is true, then it will just end, and it will just execute this and the code will end. But if not, then it will check the else if, and if both of these are wrong, then it will check else and run this. Okay, so let's just build and run this. So here is an error. Oh, we missed a semicolon. Now build and run this. Enter two numbers separated by comma. We want to enter 9 comma 5. So the answer is 9 is greater than 5. Let us try another one. We'll enter 99 comma 99. So the numbers are equal. So this is what we wanted to do. This is a basic if else statement. Apart from this, we can even write like if else statement inside if else statement, and that is all called a nested if else statement. So for nested if else statement, we are going to be running the same code, but we are going to do some addition. If the difference between the two numbers that the user enters is 100 or more than 100, then we're going to be printing the number is far greater than the other. So for that we'll be needing nested if else statement. So inside of it, as the name suggests, we will nest another if. We will write another if else statement inside of the if statement, and we'll be writing another inside of the else if statement. Okay, so for the first case we'll write if, and the condition is a minus b is greater than 100. So let us do a program. A minus b is greater than 100, then we'll have to print percentage d is far greater than percentage d. Okay, now we don't need a curly braces here, but let's just do it to be safe. Okay, now we'll give it a proper indentation to maintain readability, and let's just write the else statement for this. And the else statement will just be, I'll just copy this, Control C and Control V. Percentage d is only greater than percentage d. So this is what we wanted. Again, we're going to be repeating this again inside the else if statement. If so, in this case b is greater than a, so we'll be taking the difference between b and a. So if b minus a is greater than 100, so then we'll be printing, let's just write the curly braces to be safe. Now percentage d is far greater than percentage d, and for the other one we'll just write else and printf, again the same statement, Control C Control V, maintain the indentation to now percentage d is greater than percentage d. So let's just give a curly braces. So this is just my habit to give curly braces, because okay, now let us run this one. Yeah, so enter two numbers separated by commas. We first enter 5, then we enter 90. The difference is not 100, like it's less than 100. So 90 is greater than 5. But if we run this again, we write 100 comma 3030, then the answer is 3030 is far greater than 100. So yeah, this is the application of nested if else. It's very easy, and now we have completed almost more than half of the course, I assume. So the topic that we're going to be studying now is functions. Functions are basically a group of lines of code that does a particular task. There are two types of functions. First one is library functions, and the second function is user defined functions. We're already very familiar with the library function. For example, the printf function or the scanf function that we used were in the library stdio.h. Its implementation, its definition is in stdio.h, but we just call it. We just do part 3 of a function. We just call the function and just use it. These are the library functions, but we can define our own functions. Whenever we have to use a block of code again and again, then we just make it a function and then call the functions over and over again. So that is much more efficient than just writing the block of code whenever we need it. So let us just make a function for adding two numbers, a basic function. The first part of a function is function declaration. So let us just write the return type, which will be void, because this will not be returning anything. And we write add, and inside of it we write the parameters a and b. Add is just basically a identifier. It is just a name of the function. You can write anything there. After this we write the function definition. At the function definition we just write void add. After this we write int a comma int b, because we are going to be using a and b inside here. Now we write the implementation of the function. Right, we write here the code that is to be implemented whenever we call the function. So I just write printf, and then I write the sum is %d a plus b. Okay, so now the third part of the function is always function call. For the function call we just write the main function. First we write the main function. Inside of the main function we just call it. We just write add and then write the two numbers. Let us write 5 comma 100, and in the next step let us write add and then write 500 comma 500. Okay, we forgot to write the return 0. Yeah, so let us run this again. Let us cut this one and then run again. What mistake did we do? Okay, so we did a mistake here. Let us write this after we have closed the double quotes. So yeah, the sum is 105 for the first one, the sum is 1000 for the second one. So we just reuse this block of code basically. The next thing that I want to show you is the functions with return type. Let us not write this. Let us just cut this print statement, Ctrl X, and let us just return something. Let us return the sum of a and b. So the return type here will be integer, right? And here also we'll have to write int. Now we cannot just call this, because the add 5 comma 100 statement will give an integer in return. So we will store it in something called sum. Let us just name a variable called sum1 and sum2, okay, as an integer. Now in sum1 we'll store the first one, and in the sum2 we'll just store the second one. Now we're going to print it. We'll have to print it over here. The sum is, first of all we print the sum1, and secondly we do sum2. So this was the example where we used integer as a return type. So the result of this operation will be stored in sum1, and here it will be printed. So let us run this one. return return. Okay, the sum is 105, the sum is 1000. So this is what we wanted. These two that we wrote here, these a and b, these are called parameters. Here 5 and 100, they are the parameters. Whenever we run the program, the operating system will call the main function. The main function is different from the library functions and user defined functions.
it has the qualities, it was the qualities of both the library function and the user defined function. Basically how this program runs is, first of all, this function declaration tells the compiler that somewhere in this program there is the implementation for the add function. So if I were to call the add function anywhere, you just search the program and you will find the implementation for it. So this is just to denote the compiler that. Now in the function call we wrote sum1 equal to add 5 comma 100. Now the compiler will search for add function in the program. After this it will copy the value of 5 in A and then the 100 in B, and after that A plus B becomes 105 and it returns the value and stores it in sum1. The similar happens with this statement, and we can print it and we can just run it. Okay, and this works. So this was basically the implementation of functions. In the next tutorial we will be learning about array. Arrays are a data structure where elements of the same data type can be stored. They are very similar to variable, it's just that we can store a lot of elements in it. For example, we can write int a and inside of it we can store a number, but inside of an array, let us write it arr, we can store like as many numbers as we need. So let us make an array to store 5 numbers. Okay, so we just write int arr and then inside square brackets we just write the number of elements we want to store, and after that let us give some values to it right here. So let us write 22, 33, 44, 55, 77, 99, 1 2 3 4 5. So yeah, so these are the 5 values. Now let us try to access them. For accessing these elements we just write arr, which is the name of the array, then we write the index. The first number, the first element has the index of 0, the second has the index of 1, the third has 2, and so on. Let us try to access the first element first. So let us print this, printf, and then %d, and the value is r0. Yeah, so the value r0 is 22. If we try r2 3, then it will be like, let us cut this one first. Now if we run this, then the 55 will be printed, because this is 0, this is 1, this is 2, and this is 3, which is 55. So let us write a program to print all of these elements. For that we will be needing a loop statement. Let us use for loop. The first step is initialization. We write int I equal to 0 as an initialization, then we give the condition I is less than 5, then we give the incrementation I plus plus, and inside of it we just write the code to print. So the index of the array that we want to print is I, because it goes from 0 to 4, right? So it will ensure that all of the elements will be printed. Yeah, oh, let me just give a space here, %d and space. Okay, so 22, 33, 44, 55 and 7799. Okay, so all of these are printed. Now let us try to access the array and just enter the elements by ourselves. So we'll be needing another loop here. Let us use this one only, and inside of it we'll just write the code for scanning it. We write scanf and %d of course, and we will be storing it at the address of ri. Yeah, this is all we need. We need a comma also, and now a semicolon, and we are fine. So we just need to enter something, 22, then we enter 55, 77, 88, 9999. Yeah, so these are the numbers and they are printed. Okay, so yeah, that's it with arrays. So just keep in note that all of these elements are of the same integer data type. In a case that the array is of character data type, we can actually treat this as a variable. Okay, we can just we do not have to use the loop for taking the input or showing the output, because the array of character is called string, and strings can be treated just like variables. Okay, so for taking the input we can just write scanf, and inside of that we write percentage s denoting string, and then we write add arr. Okay, so now we can just enter that. So let us just write a printf statement here. Let us write enter the string. Okay, so this is what we want to print. Now we can enter the string here. After this we'll print the string. Printf the string you entered is, and after that we give a new line character. Then again we write another printf statement, printf, and we just write percentage s. And what is the value of percentage s? It is just arr. Okay, so it's pretty easy. Now we can just run this code. Enter the string. I'll just write Probin, and then the string you entered is Probin. But there are other cases. For example, I wrote global warning, and in this case the string you entered is global. After the space the scanf actually stopped taking the input. Okay, so in that case the scanf does not seem to be that effective. For that we use the getS function. For the getS function we just write getS, and after that we just write where to store it. We are storing it in arr. So that's it. Instead of the scanf we will use getS function. Now let us run this and write machine learning. Okay, now the string you entered is machine learning. The implementation is very easy if it is a string. There are some limitations to what an array can do. The array is great for storing a lot of elements of the same data type, but if we want to store elements of different data type, then we'll have to define our own data type for that. And that is done using structures. The keyword we use will be struct. We can define a data type outside of the main function if we want to use it throughout the program, but if we want to use it only in the main function, then we'll just define it inside the main function. Let us define it outside for safety reasons, and we write struct, then we write the name of the data type or the identifier, which is, let's say, student, and inside of it we want to write the first element. Let us make the first element int a or int roll, denoting the roll number of the student. Then we'll do character data type and name, which will be a length of 20, and then another integer one called marks. So this will basically store all the information of a student. Okay, so now for primitive data type we used to do like int a to declare a variable a. This is the same. We just write the data type name and then we write the variable. So we'll write student and then we write a, right? No, this is not how we do it. The data type is not student. The data type is struct student. Student is in itself is nothing. Struct student is a data type. So let us write struct, then we write student, and after this we write the name of the variable. Let us say class. Now we can give values to it. Let us give it here only. I'll use a curly braces and then give the roll number as 1, the name as, let's say, John, and the marks, John will get about 60 marks. Okay, now the another part of structure is accessing the elements. So for accessing the structure it is pretty easy. We just write the name of the structure. After this we write dot and we write which one we want to access. If we want to access the role, we just write class.role and assign some values to it. Okay, so we just want to print the assigned values already, so we write printf and then we write %d, and the second is %s, and the third is %d. So the first element is class dot role, the second is class dot name, and the third is class dot marks. So let us give a semicolon and just run this code. Yeah, so 1, John, and 60. This is what we wanted to print. Remember that the struct student is basically a data type and class is just a normal variable. So we can make an array out of it. Okay, so let us make an array of size, let's say 4, and let us cut this one. We'll use the for loop to take the input in the class. Let us write for. Since we are entering 4 elements, we'll do from I equal to 0 to I is less than 4, I plus plus. Yeah, inside of this we will first write printf, enter the roll number, enter the roll. Then we will do the scanf, percentage %d, and we will be storing it at the address of what? Class dot class, and then we have I dot roll. Okay, now for the next one we'll be doing printf, enter the name, student's name. For this one also we will be doing a scanf function. We do percentage %s this time, and we will store it at the address of class I again, and dot name. Again we'll use another printf function, enter the marks, and again this is the same, I think. Control C, Control V, class I dot marks. Yeah, so this is the function, this is the loop for taking the input. Now we'll have to make a loop for displaying the output. Let us again use the same loop here, and inside of this loop we will be just printing. We'll use printf, and then the first thing to print is some space, maybe some this is \n. Okay, the new line character is always \n, so we'll be using some spaces, and after that we'll be writing yeah. So first of all, let us just cut this one, and before the loop starts we'll be writing that the in capital we'll be writing that the data of marks of the students is, and after this we'll give another few new line characters. Yeah, now inside of this for loop we are finally ready to print. We'll print printf, and after this the first thing is the roll number, which is %d. After this we might need a few spaces, then we print the %s, which is the name, and after a few spaces we'll do something like %d, or we'll do like marks and then h2 and %d. So for the first one the value will be roll, which is class I dot roll, class I dot roll. We don't have to use the at as the printf function. Again we'll have class I dot name, then we'll have class I dot marks. Yeah, so these three will be printed at the places of these, and after this we might want to add a new line character because there will be 3 lines, right? So we need a new line character there. So this is basically it. We need to close this one. Let us build and run this. So here is some error. We just forgot to give a semicolon here. I is undeclared. Oh, we forgot to declare I also.
Here also we missed a semicolon. That's it. Enter the roll number, we'll do 1. Enter the student name, John. Enter the mask, 40. Enter the roll, 2. Enter the name, Mary. And enter the marks, 50. Enter the roll, 3. Enter the student's name, Ilan. And enter the mask, 99. Enter the roll, 4. Enter the student's name, Mark. And enter the mask, 88. Yeah, so the data of the marks of the students is 1 is John and 2 is Mary and the 3 is Ilan, 4 is marks, and the marks are as follows. So this is basically the implementation of the arrays in a structure. In this program we learned a lot of things. First of all, we learned how to use arrays, we learned how to use structures, we also revised how to use the looping. Yeah, so this is the end of the tutorial. In a very short time, you've learned a lot of concepts about programming in general and of course the C programming language. So congratulations to you on completing this course. This is also the first video on this channel. So I'll really appreciate if you'd subscribe. You can like or dislike, of course. I plan on uploading a lot of other tutorials, coding stuff, projects, etc. in the future. So with that said, I will see you in the next video. Bye.